Elements, atoms, ions. Why sulfide ions have a charge of 2? They have 2 more electrons than protons. Explain, in terms of the number of outer shell electrons and electron transfer, how calcium atoms and chlorine atoms form ions. Give the formulae of the ions formed. Ca has 2 and Cl has outer electrons 7, 1. Ca atoms lose electrons 1. Cl atoms gain electrons 1. Ca2 plus ions 1. Cl ions 1. In terms of electron transfer, what happens to ions in this reaction? Lose an electron. Definition of relative atomic mass. Relative atomic mass is the average mean mass of naturally occurring atoms of an element on a scale where the 12C atom has a mass of exactly 12 units. Describe why these gases diffuse. Because of the random motion of particles. Explain, using ideas about particles, why ammonia gas spreads throughout the laboratory. Particles move from an area of high to low concentration. Particles move randomly. Which of these 4 gases has the highest rate of diffusion? Hydrogen. It has the lowest molecular mass. Brass is an alloy of zinc. Explain, in terms of particles, why brass is harder than pure zinc. Exists as layers 1. Alloy contains different sized copper atoms 1. Makes it more difficult for layers of atoms to slide over each slip, shift other 1. State what is meant by the term isotopes. Atoms of the same element, with a different number of neutrons. State why these 2 isotopes of chlorine have the same chemical properties. The same number of electrons and therefore the same electronic configuration. Explain in terms of electron transfer why phosphorus behaves chemically as a non-metal. Gains electrons. 3 electrons when forming ion. Describe the separation, arrangement and motion of particles of element X in the solid state. Separation, touching, arrangement, regular, motion, vibrates, bonding. Describe the bonding in a metallic element such as sodium. Positive ions, cations 1. Sea of electrons, mobile electrons, delocalized electrons 1. Attraction between positive ions and electrons 1. What is an ionic bond? Oppositely charged ions. Ions are attracted. Sodium chloride does not conduct electricity when solid, but does conduct electricity when molten. Ions are fixed in a lattice. Ions are mobile. Why nitrogen does not conduct electricity? Do not have ions. Explain in terms of attractive forces between particles, why nitrogen has a low melting point. Because the forces of attraction between the molecules are very weak. Explain, using your knowledge of structure and bonding, why magnesium fluoride has a high melting point. Forces of attraction between oppositely charged ions, ionic bonds 1. Strong, need a lot of energy to break, weaken 1. Explain, using your knowledge of structure and bonding, why carbonyl fluoride has a low melting point. Forces of attraction between molecules 1. Weak, need a small of energy to break, weaken 1. Electrolysis. State the meaning of the term electrolyte. M1 ionic compound and either molten or aqueous or both 1. M2 conducts electricity, undergoes electrolysis 1. State reasons why carbon, graphite, is suitable to use as an electrode. Inert property. Good conductor of electricity. Why does the pH increase during the experiment? Increase 1. H plus ions being removed 1. Explain how sodium hydroxide is formed. H plus and Cl are discharged, removed 1. Na plus and OH remain 1. Describe the role of cryolite in the extraction of aluminium by electrolysis. Aluminium oxide has high melting point, cryolite has lower melting point than aluminium oxide. Using cryolite reduces costs, expensive to melt aluminium. Lower melting point, lower operating temperature, better electrical conductivity and acts as a solvent. Describe one environmental advantage of reducing the operating temperature. Less CO2 emission. Magnesium fluoride does not conduct electricity when it is solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, explain why magnesium fluoride conducts electricity when this change is made. Heat until molten or dissolve in water 1. Moving ions, mobile ions 1. 4OH right pointing arrow O2 plus 2H2O plus 4E. Explain why the carbon anodes have to be replaced regularly. Anodes are carbon react with oxygen 1. Form carbon dioxide 1. Boiling points. Explain, in terms of attractive forces between particles, while Li is a solid at room temperature but NCl3 is a liquid with a relatively low boiling point. Ionic bonds in Li. Attraction between molecules in NCl3. Weaker attraction between particles in NCl3 aura. Use your knowledge of structure and bonding to explain why lead-2 oxide has a much higher melting point than carbon dioxide. M1 bonds between ions or ionic bonds in lead-2 oxide 1. M2 attraction between molecules in carbon dioxide 1. M3 weaker attraction between particles in carbon dioxide aura 1. How is the boiling point of water affected by impurities? Higher boiling point greater than 100 degrees Celsius. Equilibrium. What is equilibrium? The rate of forward reaction equals the rate of the reverse reaction. Concentrations of reactants and products are constant. 1. Explain why the position of equilibrium does not change. 2Hig I2G plus H2G. Same number of gas moles on both sides. Suggest why the color of the gaseous mixture turns darker purple even though the position of equilibrium does not change. Iodine particles or molecules forced closer together, same number of iodine particles or molecules in a smaller volume. Increased pressure. Equilibrium shifts to LHS 1. Forward reaction is exothermic 1. Increased temperature. Equilibrium shifts to RHS 1. Fewer moles of gas on RHS 1. Observations. What are the observations that indicate that the zinc carbonate is in excess? When no more zinc carbonate dissolves and some solids are left behind, solids undissolved. No fizzing. Describe the observations when potassium is added to cold water. Moves, floats, dissolves, disappears, bubbles, effervescence, fizzes. Lilac flame, explodes, melts, forms a spherical shape. 2 kiloseconds plus 2H2O(L), right pointing arrow 2 KOH, AQ plus H2G. Hydrated copper 2 sulfate is heated. What is observed? The solid changes from blue to white. White fumes are given off. Condensation at mouth of tube. Rate of reaction. Why does using powdered zinc instead increase the rate of reaction? Powder has larger surface area, or lumps have smaller surface area. Powder has more collisions per unit time, more collision frequency, or lumps have fewer collisions per unit time, less collision frequency. Step 1 is repeated without heating the dilute sulfuric acid. The rate of reaction decreases. Why? Particles have less energy. Fewer collisions between particles occur per unit time. A smaller percentage of collisions of particles are successful, have energy above activation energy. Explain, in terms of collisions between particles, why the rate of reaction increases at a higher temperature. M1 particles have more kinetic energy, particles move faster 1. M2 more collisions per unit time 1. M3 more particles have energy greater than or equal to activation energy, or more particles have sufficient energy to react, or a greater percentage or greater proportion or greater fraction of collisions have sufficient energy to react. In terms of particles, explain what happens to the rate of this reaction when the temperature is increased. Particles gain kinetic energy, particles move faster 1. Greater number of collisions with activation energy, or more greater number of particles with activation energy, or more greater number of particles with energy required for reaction 1. More collisions are successful, more collisions are fruitful, more collisions lead to reaction 1. Describe how the graph shows that the rate of this reaction decreases as time increases. Gradient of line decreases. Explain, in terms of particles, why the rate of this reaction decreases as time increases. Concentration of particles of acid decreases. Concentration of HCl is decreasing, or answers in terms of numbers of reactant molecules decreasing. Lower rate of collisions of particles. Why does the volume of O2 decrease as time increases? Rate decreases 1. Particles further apart, less particles per unit volume 1. Fewer collisions per unit time, lower collision frequency 1. Reaction stops because all hydrogen peroxide is used up. Define the term activation energy. Minimum energy that colliding particles must have to react. Transition elements. Difference in the physical properties of G1 elements and transition elements. Group 1 element is less strong, not strong. Group 1 element has low density aura. Group 1 element is soft aura. Group 1 element has a lower melting point. Chemical property of transition elements. Act as catalysts. Variable oxidation state. Similarities between G1 and transition elements. A good conductor of electricity. It forms a basic oxide. Form soluble salts. Form hydrated salts compounds. Shiny. Metals. Give properties of aluminium that make it suitable for use in overhead electricity cables. Ductile, malleable. Conducts electricity. Low density. Protective oxide layer. When aluminium foil is added to aqueous copper 2-sulfate, no immediate reaction takes place. Why? Unreactive coating of aluminium oxide. Tests. Describe how to test a liquid to show it is pure water. Measure the boiling point. 100 C. Saturated solution. A solution that can dissolve no more solute. At a given temperature at the specified temperature. How does a chromatogram show that this substance is not pure? It has more than one spot. Describe the test for a nitrate ion. Add aqueous sodium hydroxide. Then, reduction with aluminium foil and warm. Ammonia gas produced which turns damp red litmus blue. Describe how to do a flame test on a sample of a salt. Compound salt on wooden splint or nichrome platinum wire 1. Into roaring Bunsen flame 1. Describe 2 simple experiments to show that zinc oxide is amphoteric in the observations you would make. Add at named acid 1. Add at named alkali 1. Disappears dissolves in both 1. Haber process. Essential conditions in the Haber process. 450 degrees Celsius 1. 200 atmospheres 1. Iron catalyst 1. N2 plus 3H2 rightwards harpoon over leftwards harpoon 2NH3 1. How nitrogen is obtained for the Haber process. Fractional distillation of liquid air. State 1 source of hydrogen used in the manufacture of ammonia. Hydrocarbons reacting with steam. Explain why a lower temperature and a higher pressure are not used. Lower temperature. Rate of reaction slower 1. Higher pressure. Expensive specialist equipment. Contact process. How is sulfur converted into sulfur dioxide in stage 1? Heat in air. State the essential conditions that are necessary for sulfur dioxide to react with O2 to form sulfur trioxide. Describe how sulfur dioxide is converted into sulfur trioxide in stage 2. 200 kPa ATMP. 450 C. Vanadium V oxide. 2SO2 plus O2 right pointing arrow 2SO3 1. What is sulfur trioxide reacted with to convert it into oleum? Concentrated sulfuric acid. Oleum is converted into sulfuric acid in stage 4. Write a chemical equation for the conversion of oleum, H2S2O7, into sulfuric acid. H2S2O7 plus H2O right pointing arrow 2H2SO4. Prepare something. How to prepare a limewater starting with solid calcium hydroxide. Add excess solid calcium hydroxide to water. Filter. Describe how crystals of calcium chloride can be obtained from the mixture left in the flask after the reaction has stopped. Filter to remove calcium carbonate 1. Heat to evaporate water 1. Until crystals start to form. Point of crystallization until saturated, then leave to cool until half evaporated. Describe how to prepare a pure sample of sodium sulfate crystals from the original solutions of dilute sulfuric acid and aqueous sodium hydroxide of the same concentrations. M1 repeat without indicator using same volumes or remove indicator by adding charcoal or carbon and filtering 1. M2 evaporate heat warm boil leave in hot place 1. M3 until most of the water is gone, some water left saturation point crystallization point evaporate some of the water 1. M4 cool leave to crystallize 1. M5 description of drying 1. Salts that are soluble in water can be made by the reaction between insoluble carbonates and dilute acids. Zinc sulfate is soluble in water. You are provided with solid zinc carbonate, ZnCO3, and dilute sulfuric acid, H2SO4. Describe how you would make a pure sample of zinc sulfate crystals. Your answer should include filled circle practical details. Filled circle how you would make sure that all the dilute sulfuric acid has reacted. Filled circle a chemical equation for the reaction. Add zinc carbonate to sulfuric acid until it stops dissolving or no more effervescence 1. Filter zinc carbonate 1. Evaporation of filtrate to form dry crystals 1. ZnCO3 plus H2SO4 right pointing arrow ZnSO4 plus CO2 plus H2O. CO2 product in equation 1. Rest of equation correct. 1. Explain why crystals form as the solution cools in step 4. The solubility of ZnCl2 decreases as the temperature decreases. Make insoluble salts through precipitation. Add water to both salts. 1. Dissolve both salts. Make solutions. 1. Filter lead 2 iodide. 1. Wash residue of lead 2 iodide with water and dry, e.g. with filter paper. Description of washing and drying. 1. PB number 3 2 plus 2 Ni right pointing arrow 2 nano 3 plus PBI 2. ORPB 2 plus 2 I right pointing arrow PBI 2 1. How can student be sure that all the water is given off? Heat plus weigh plus repeat. 1. Until mass is constant. 1. State how the student decides that a suitable number of results have been obtained. At least 2 results are within 0.2 cc or less. Describe how propanol can be obtained from the mixture using a condenser through fractional distillation. Use data from the table. Heat to remove the ethanol. Collect propanol at 97 degrees Celsius. Organic chemistry. State 2 general characteristics, other than the same general formula, of all homologous series. Same or similar chemical properties or reactions. Contain the same functional group. Consecutive members differ by CH2. Physical properties vary in predictable manner, show trends gradually change. State why this is an addition reaction. Only one product is formed, double bond becomes single bond. What does the term condensation mean when used to describe this type of polymer? Water is a product when polymer is made. Give 2 advantages of manufacturing ethanol by fermentation compared to manufacturing ethanol from ethene. Carbohydrates are renewable. Fossil fuels are non-renewable, or fossil fuels conserve. Lower temperature, or lower energy. Hydration is equilibrium, meaning lower yield. Lower pressure used. Name given to compounds with the same molecular formula but different structures. Structural isomers. Name the reagent and suggest the conditions needed to convert propanoic acid into propan-1-OL. Reagent. Steam. Conditions. H3PO4, 60 atmospheres, 300 C. Name the type of natural polymer formed when amino acids combine. Protein. How to form ethanoic acid from ethanol. Ethanol will react with hot aqueous potassium manganate, 7. Acidified. State what is meant by the term functional group. The atoms are group of atoms which give chemical properties. Name an example of a polyester. Pterylene.